Hello student, today I will start a new topic, that is ion selective electrode. Okay, so here in this lecture I will discuss the working of ion selective electrode, what is this, how it works, and the application of the ion selective electrode. Okay, so we have already known that potentiometry is an important technique in electroanalysis which gives information about the sample composition by measuring the potential established across a membrane. Different types of membranes are produced with different ion recognition machines to increase the selectivity and sensitivity. Okay. These electrodes are used for decades for the detection of various ionic species like hydrogen, potassium, calcium and fluoride in complex samples. In contrary, potentiostatic technique deals with the study of charge transfer at the liquid electrode interface. Here the electrode potential is used to derive an electron transfer reaction and the resultant current is measured. Electroanalysis can be carried out only when the medium between the two electrodes is conducting. This technique offers low detection limit, high sensitivity, large linear dynamic range, precision and accuracy with a low cost instrumentation. There are a number of important benefits associated with the use of electroanalytical techniques, like the important benefits like selectivity and specificity, low detection limit with high sensitivity, choice of electrode material, results are real time or near real time, miniaturization of the sensor. Okay, so ion selective electrode or ISE are capable of selectively measuring a particular ionic species. These electrodes are classified as membrane electrodes containing an ion permeable membrane that separates the sample from the internals of the electrode. The main advantage of using ion selective electrodes are that they are insensitive to color, viscosity or suspended solids. They are also tolerant to small changes in pH. Okay. Response time and reversibility are critical for the performance of this sensor. The problem of reversibility, considering all electrochemical process as equilibrium process, are the contribution of Nernst. Okay. Nernst equation states that the change in potential is proportional to the change in ion activity in logarithmic units of the system. Ion selective electrode measurement involves the use of two electrodes. One is working or indicator electrode and other electrode is the reference electrode, whose potential is fixed irrespective of the solution used. The potential that is proportional to the activity of the sample ions is measured across these two electrodes. Okay. So the potential that is proportional to the activity of the sample ion is measured across these two electrodes. Okay. So see, ion selective electrode is an analytical technique which is used to determine the activity of ions in aqueous solution by measuring the electrical potential. Ion selective electrode has many advantages compared to other techniques, including number one is it is relatively inexpensive and easy to operate. It has wide concentration measurement range. Third one is as it measures the activity instead of concentration, it is particularly useful in biological or medical application. Fourth is it is a real-time measurement, which means it can monitor the change of activity of ion with time, and it can determine both positively and negatively charged ion. Okay. So based on these advantages, ion selective electrode has wide variety of applications, which is reasonable considering the importance of measuring ion activity. For example, ion selective electrode finds its use in pollution monitoring, in natural waters, food processing, in Ca2 positive in dairy products, and potassium in fruit juice, etc. Okay, so these are the ion selective electrode. Okay, and based on this advantage, ion selective electrode has wide variety of application. Okay, which is reasonable considering the importance of measuring ion activity in a solution. Okay. Now see, before focusing on how ion selective electrode works, it would be good to get an idea what ion selective electrode setup look like and the component of the ion selective electrode instrument. That means the instrumentation of ion selective electrode. Okay. So this figure shows the basic components of the ion selective electrode setup. Okay, so see the figure, it has an ion selective electrode which allows measured ion to pass but excludes the passage of the other ions. Okay, within this ion selective electrode there is an internal reference electrode. So within this ion selective electrode there is an internal reference electrode which is made of silverware coated with solid silver chloride embedded in concentrated potassium chloride solution saturated with silver chloride. Okay, this solution also contains the same ions as that to be measured. There is also a reference electrode similar to ion selective electrode, but there is no to be measured ion in the internal electrolyte, and the selective membrane is replaced by porous frit, which allows the slow passage of the internal filling solution and forms the liquid junction with the external text solution. The ion selective electrode and reference electrode are connected by a millivoltmeter. Okay, so measurement is accomplished simply by immersing the two electrodes in the same test solution. So this is the measurement setup of ion selective electrode. Okay, now the rest part of this lecture I will discuss in the another presentation. Okay.